Okay. Hello, everyone. I keep forgetting that when I do this, I'm basically just always talking to myself. Let me get that out of the way so you can see me. Hello. Welcome to our Let's Build Python 101 Part 2, part of our Global Hack Week season launch, or our whole entire season launch, not just Global Hack Week. Hi, how's everyone doing? Hello. Welcome into chat. First thing, I did see a few things in chat. Excited for the second part. Me too. Hopefully, there's a lot to learn, a lot going on. And it looks like generally these multi-tracks sometimes drop a bit in attendance, which is perfectly fine, which means there's more time to explore and do some fun stuff. But mentioning attendance, help me keep track of that. Please make sure to check in. I'm going to drop the check-in link in the chat for you all. There we go. And that way, if you're on not just on Twitch, thank you. I really appreciate that. Thank you. Yeah, next year is going to be you. I'm going to see every one of you guys as a top 50 next year. But yeah, thank you for joining me today. Let's get going. Thank you. Appreciate it. For everyone in chat, wouldn't be here without you guys. You guys are the sole consumer. Thank you. Appreciate it. And again, I'm promising you, next year it's gonna be one of you guys, at least one of you, right? We have like what? I think we have like 10 people, 15 people across the platform right now. One of you guys have to make it next year. Okay. Water time. Okay, let's get going with today's slides. There's less slides today because we're going to be doing a lot more playing around. We're really building our fundamental skills and learning syntax and how files work, file structure for our tomorrow's workshop, which is we're going to attempt to build a Discord bot together. And I think I'm pretty set on that. And it's going to be a fun one because I've never done it myself. So I'm going to be equally as in the dark. Some of you guys might have done it even more than I have. It is going to be a fun thing to do to build together and so on and so forth. But with that being said, let me put you guys here so I can see you guys better. Okay, cool. Yeah. Okay. With that being said, let's get started. So if you guys don't know me, hey, I'm Kev. I'm a coach here at Majorly Hacking, and I use the he, him, his pronouns. I do a lot of different things. So I'd like to say feel free to ask me about anything. I touch upon a lot of different sectors within tech, especially computer science. I've done like telecommunication, I've done AI and data science, I've done high performance computing before. I've done a lot of different things. So yeah, I always welcome any conversation, even if something I'm not good at. Love to talk about it, love to learn more, love to hear your thoughts, and so on and so forth. With that being said, today's schedule overview, it's pretty light day. Well, I guess the last one was also pretty light, but it's light in terms of the amount of content we're going to cover is not that much. We're going to do, after covering content, we're going to polish on some of those content and ideas. Hello, welcome to chat. Welcome. Hi. That was such a change in enthusiasm. I really like that. So welcome. But yeah, so we're going to first talk about control flows. And we're going to talk about if, which includes, but not limited, which we're going to talk about if, and else statements. We're going to talk about logics. We're going to talk about loops, and we're going to talk about functions. I missed day one, which is perfectly fine. You don't need day one. Yeah, and if you coded before, we're just going to do Python. And day one is really a lot of fundamentals in computer science. So if you coded before, you really don't need day one. Feel free to pick up where we are right now. I appreciate everyone when we welcome our new comers to our stream. So thank you. But yeah, with that being said, I didn't forget. I just remembered. Let me get this music queued up for you guys. So you guys get a bit of less quietness. Let's see. Hello. Welcome. Yes. It's gonna be a breeze if you coded before. It's pretty light refreshers. Ask me anything in chat. Let's get that going. And then let's pick a song. I haven't played this one. There's a lot of different BPM versions. I'm gonna put the highest one on. I can't hear it, but when you guys want a music change, just let me know, and we'll give that a change. I like that face right there. Just X. Okay, cool. So with that being said, let's get going for the day. We're going to skip this, actually. We're going to come back to this later because most of us have set it up. If you haven't, we'll work on that at a later time. And before that, let's dive into our content. So the first topic we're going to talk about today is called control flows. To a soft one, yes. Is it loud? When you say soft, you mean like... Here, I'm going to drop the volume by a tad bit. in case you're talking about the volume. And then I will drop this to maybe this one. If you have any opinion on the music, let me know. I wish we had more tracks, but unfortunately, those are the tracks we have. If you know how to make music and you can make me royalty-free music and give me the rights, I need this in writing, maybe I can convince and add them to the stream. As long as they're appropriate, really neutral, and royalty-free. And I have the right to use them. But yeah, unfortunately, in the streaming business, we don't have the right to use everything, so that's unfortunate. But yeah, cool. So we're going to talk about control flows. So what are control flows? So there's 3 types of control flow. This slide is really bare minimum, and because I'll do something, one of my favorite things in a second. The 3 types of control we're going to talk about is sequential, conditional, and iterative. I don't know, I can say that for a second. Sequential, conditional, and iterative. And you might ask me, what are they? And today, it's going to like a regular classroom. We're going to go to our whiteboard, which is just my paint instance. And we're going to paint this all out. So now I need to move you guys over here. That way I can access my paint. Okay, so we're going to talk about control flow today. So control flow. What is the idea of the word control flow? I'm actually going to maybe blow this up a tad bit and then write smaller so you guys can see bigger. Let me see if I can do that. Okay, so what is the idea of this word, control flow? All this means essentially is how when you're, whatever the computer interprets your program, how does it actually read through it? And we thought that there's a few different. The first one was yes. This is a good definition. I'm going to go into it, but this is a good one. Control flow, or the flow of control, is the order in which individual statements, instruction, or function calls of an interpretive program are executed or evaluated. The emphasis on the explicit control flow distinguishes an interpretive program from a declarative program language, which is the interpretive and declarative program languages is also the difference between I'm still blinking, but yeah, that was a really good definition. But yeah, so we're gonna break down each one of them in the different type of control flow that there is. So the first one we're gonna talk about is called sequential. Well, sequential, all that means is in interpreter language is sequential. I can't spell, but just remember, pronounce that as sequential. All that means is your code or your computer or the interpreter, as it's interpreting each line of code, it goes in exact order. So, right, it goes in sequence. So if I have line 1 here, line 2, 3, 4, 5, the computer will read this as it will start line 1, it will read this in, it will then start line 2, line 3, line 4, and line 5. That's one of the most simple and basic ways of control, right? So generally when you don't introduce, in Python at least, when you don't introduce another key argument and you just write code, for example, like what we wrote before, like if I wrote A is equal to 3, and then B is equal to 4, and then A plus B is equal to, well, I'm gonna pretend we're an interpreter, right? So I just would write this, and I do B is equal to 5, and then I do A plus B again. And interpreter, it'll just toss it out. Control, transfer, and integrative. Conditional, transfer, and integrative. Yes, those are more precise types of control flows. I don't know even some of them. I might not know some of them by word, but the 3 really common ones, which are the 3 I mentioned. But there are so many different type of control flows, right? Because any type of like mentioned above, any type of way that modify the control of a program can be deemed as a new type of control flow. So the 3 most common one that you see as you're learning computer science would be iterative, conditional, and repetitive. Or I think I might use a different word. But I mean sequential, iterative, and conditional. Yeah. Yes. Okay, cool. Yeah. So for example, if I wrote this program out in Python and I gave it to interpreter, how interpreter read is to read this one first, right? So it does 3, it sets 3 to A, sets 4 to B, and then there's A plus B. Sequential is line by line. That's exactly correct. I'm gonna click on that. That is 100% correct. And so what chat anyone in chat, what does A plus B? What would this like output in the console? What is this? I'm just gonna draw a question mark. It's 7, right? Okay. And my question for you, whoever said 8, I'm gonna toss you out a window. If you're saving, it's 7. Yes, right. So this is 7. So the question is, why was it not 8, right? And the answer is because there's currently no other things going on, which means if I just wrote this in a Python interpreter, it reads sequentially from top to bottom, sequentially from top to bottom, which means it does this operation first, this operation next, adds them, you get 7, then it changes B to 5, and then this one will give you 8. And if there are, maybe if we introduce the other 2 type, we could be able to do other type of control flow, which means we can change how your interpreter flows through the code, which means, for example, instead of maybe going this line, and then this line, you can go this line, skip this line, and then go to this line, and so on and so forth. So now we're going to take that out. So we just looked at sequential, right? That's a pretty self-explanatory one. If you don't add anything, your interpreter generally will be doing sequential control flow. The next thing we're going to talk about is our conditional control flow, right? So our conditional, this then leads us to our next really big topic. So first we're going to do conditional, right? So this is our next control flow type. And that leads us to our next topic, which is in conditional control flows, you have things that work off of condition, just like how it sounds, right? So the first concept we have would be if, okay, that's a bad color. Keep that out. I'm going to go back to black. Is if statements, right? So they're your pretty general logical statements saying like, if something happens, right, then do something. Right, that's how they're structured, right? And on top of that, you might have more to that, right? Because normally you can build them on. You can say if something happened, do something. But if something else happens, do something else, right? And you can say if none of those happen, and anything else happens, do something, right? This is conditional. There might be more names for it. I know this as conditional, but if you might know this by another name, that's perfectly fine. Right, and because there's a lot of things that can fit under the conditional branch of type of statements. But yeah, so with that being said, for example, let's write one out, right? So if let's table out some code actually. So in Python, the structure will look like this. I'm going to write out the whole structure and then I'm going to go over each one. So I just kind of wrote out what this looks like, right? So if something happens, so this is your condition. This is what happens based off the condition, right? So it's kind of like cause and effect, right? So this is the cause, is when the condition is triggered. Then here's the effect that happens because of said condition. So it's condition, then the effect, and then the condition, then the effect. And then we're going to put this all together. So in Python, if I was to be writing a if conditional statement, we're going to do like if let's say A is equal to 5, which is not, you can't just do that, right? What was the mistake I just made right there? And I remember we kind of went over this yesterday, and I remember what the mistake I just made. 2 equals, yes, exactly, right? We're doing a comparison, which the actual operator is 2 equals. So if A is equal to 5, and Python, you would then use, these are colons, and then this is the condition, right? I'm gonna take this and I'm gonna write condition. And then anything underneath it, like right here, is gonna be the effect that trigger if that condition is met. So if A is equal to 5, maybe then I would set B is equal to 3, right? And then I can write a next statement, which is I can do if, or it's normally else if. In some programming languages, you have to write the whole thing out. It's like else, E-L-S-E, if, right? But in Python, we just shortcut it to elif because we're lazy. So it becomes elif, which just stands for else if. So it's saying, oh, check this condition first. If this condition isn't met, check the next condition. So we're going to do elif. And what happened is we can do elif is a is equal to, let's say, 6. And then we can say b becomes 4. Right? So you see how I'm nesting here? So Python is also, we talked about this before, is a syntax-based language. Whatever spell, yeah, right? What that means is that how Python actually interprets and reads through the code, how it knows where to look for delimiters is it looks for spacing. So you would look for tabs. So this is just a tab in, and that's how it knows if this is nested in, it knows that this is the main statement, and then this is everything that's a substatement of that main statement. And it will know to first know that this is the conditional and this is what's being ran if the conditional is met. You're right, there is also else statements. But before we do that, we want to explore the idea that you can have more than one elif statement, right? Maybe I check this one, I check this one, I want to check something else, right? Maybe I also want to check elif a is equal to 0. And then b would be 5 in this case, right? So for this, what that all this says right now is saying it checks the first if statement. If their statement is met, it'll set b to 3. If it checks the second if statement, if let's say okay, I'm gonna go back real quick and reword that see so that makes more sense. Whoa, I did not know I drew that many times. Okay, cool. So let me erase that. Doop. Okay, cool. So let's try that real quick again. So what I meant to really say is if it checks the first if statement, if the first if statement requirement is met, it will not check anything else. It will stop the termination. Well, it will change the control, right? We talk about the flow of control flow. It will change the flow of control away from this this block. We call this a code block, right? So this block of if statement. So we call this the if block, right? So it's one block of if, and we call it the if block because only one of these are executed. So in each if block, only one condition can be executed. Condition, and each if block can be executed. So in this case, if the first if block execute, what happened is, let's say this is line 1, it can't be right? So this is line 1, this is line 2, this is 3. Well, I should probably write that in a different color when I pick this. So this is line 1, this is line 2, this is line 3, this is line 4, this is 5, this is 6, and there's 7 somewhere down here, right? But no, boop, boop, boop. Okay. Do you need the print statement as well? Yes, if you want to do something, you need a print, right? I'm just writing the if blocks of if code. There's nothing that's happening. So if you just ran this code right now, all it does is sets things to things. It actually doesn't do anything. But we're just trying to understand the idea of how if blocks actually work, right? So in each if block, only one condition is ever actually executed or reached. Right, so if the first one execute, what actually happened is it will say, okay, condition on line 1 is met. It will say, okay, execute things underneath line 1, so it'll execute line 2, and then from there it will say, okay, now that's all done. This if block ends at line 6. It will then jump to line 7 and resume execution here. So it'll go from here to here and skip everything between. Yes, it's like I can write code. I'm just not outputting anything for the user to see. But everything is right there. Well, I'm currently not outputting anything, right? Your code can always be doing something, but in this scenario, I am not actually outputting anything, so there is no need for me to write a print statement. So now we're going to talk about, so we explored how like you can have if, you can have elif, you can have else, right? And these are what makes up of your if block, right? This is what makes up your if block. And now it's like, okay, so what is the core part of the if block? And here are the core parts. You can have an if statement by itself, right? Let me do that cleaner. So I'm gonna, oopsie, I grabbed the edge of our screen. So I'm gonna cut this off. So here are the different types you're allowed to have. You can have an if statement by itself. You can have an if statement with just a elif statement. You can have an if statement with just an else statement. You can have an if statement with an elif statement and an else statement. You can have an if statement with multiple elif statements, and then an else statement. You can have an if statement with multiple elif statements and no else statements. So between these, you can see the only really key one that you always need to have is the first if. That's what initializes your conditional block. After you have so you must have one if. That's a requirement. You can have as many or none. So I'm gonna do infinity. Oops. So you can have as many, or you can have none. Or I should just do numbers, right? 0 dash elif statements. You can have 0 or 1 else statements. And that's what makes up the block. You can also do break. Yes, we're going to explore break, but break is a concept that becomes a lot more prevalent in loops, which is the iterative control flow, and less so in conditional control flows, right? Because in conditional, only things will execute once a condition is hit, and not always a condition is hit. But yeah, so this is your if statement. So you can have one if, you can only have one if in an if block. If you write two if, you're starting two if blocks. At every if block, there can be one if statement. There could be unlimited or 0 elif statements or else if statements. There could be 0 or 1 else statement. But realistically, in my personal opinion, for good programming practice, you should always minimally have an else statement, right? This is really just a catch-all case, right? You might think you have caught everything, but if something, let's say, happened, somehow radiation changes a bit in your computer and it didn't operate like normal, you want that else statement to catch everything else, right? This is your catch-all, right? So in like the complete build-out structure, this is condition 1, condition 2, condition 3, you keep checking, and this is your catch-all. This is your net. This is supposed to catch everything that somehow falls through the rest is caught by else, right? So the recommendation I generally have for everyone, especially who's new, is you can write something else, right? Else can just be it prints something, so you know that it hits the else statement. Else could be it meets a certain criteria, but write a case that essentially if everything fails, it get caught. So that was conditionals. Now we get to the more funner topic, but not really. I just say it's funner, which is repetitive control flow. Any questions in chat for right now, though? Irritate. Okay. Oh, yes, thank you. I meant to say that. Oh, if you can't tell, I'm so out of it today. Iterative. Thank you, chat. That's exactly what I meant. That's why I said. You have no proof otherwise. That is correct. Yes, Python does have switch. We're actually going to go over switch in switch cases, which is actually a type of conditional, right? We're going to go over switch cases. So Python have something. It's a tad different. It's called, I forgot what's what called. It's like, what is it called? I can't remember. What is it called in other language? Python, it's called match. So it does match, and then it does cases. You also have a switch in cases, I think, if I'm not wrong. Or if I am, it's just match in Python, but it operates basically the same way as a switch case. We're going to go over that in a little bit. Yeah, okay, cool. So with that being said, we're going to go over iterative control flow, which for most people, one of the most basic loops that we understand, right? Well, all right, let's start. One of the first basic thing is loops. And with that being said, there is two real type of loops. And then I'm going to say one fake type of loop, but that's not even really realistic. So there's two actual types of loop. Actually, this is probably better. There's two actual types, but there is actually three like fake types of loops. And the reason I say that is because in the 2 actual type loop we have is just called a for loop. And then the one above that is called a while loop. But for loops are then broken into 2 cases generally. So we in Python, we have something called for each loop and then a for I loop. For I is like in most of your programming language, it does your indexing. So it's an index-based loop. For each loop is a more unique loop to Python because of how high-level language it is. It allows you to iterate through each object. While while loop is your standard good old while loop. So with that being said, we're going to take a look at first is the for loops. So for each loop, how it works is with the general for loop structure. Let me read this real quick. Unlike C++, Java, Ruby, and other programming languages, Python does not provide a switch case statement, but it offers a few workarounds to make this statement work. Yes, there is replacements, and there's something pretty similar, which is like a match, but there's no exact thing as a switch. I love it when everyone just helps each other out. Oh, really? That's funny. Yeah, but guess what? If I really wanted to do that, I can probably just go like watch this. There we go. I can just draw on white. Look at that. Yeah, Python always introduces new things as they build. It's pretty cool. There we go. So with that being said, going back to what we were talking about, we're talking about loops. So we're going to start with for loops, right? So we have for each, which in the general structure in Python, it's for something in something, right? So it's for blank in blank. And the for each loop, so in the for each loop style, it becomes for, you make a variable name. So this is just a variable placeholder in something that's iterable. So like a list, right? So in like, I'm going to make a list up here. So if you remember, we can make a list. I'm going to make a list called A. A is equal to a list of numbers. This is stupid, but just bear with me for example purposes only. Yep, it is. Match is essentially almost identical. If the only thing I can't say it's identical because I don't know if it is 100% identical, but it's close enough. But yeah, so for var in something, and this is a for each loop because what actually happened is this variable, whatever you name it, so maybe I name it number. So for num in A, what allows you to do is this number will then take on the form of each item in this list, and it does this. And that means whenever you reference num underneath the body of this for loop, you'll be able to use it as 1, 2, 3, 4, 5. And so for example, if I did like print 1 plus num, right? It'll print out 2, then we'll print out 3, 4, 5, 6, because it'll iterate through this whole entire list until it exhausts the whole list, and it'll become each item in this list, or each value in this list. I'm gonna clear that, and since there was a complaint, I'm gonna dump this again, and then we're gonna go back to white. But before that, we're actually gonna take a trip. This is like the fun part of today's exercise. Is we're gonna go here. We're gonna hit F1. So if you were here with us, I mean F11. If we were here with us yesterday, we started a Replit. If you were not with us yesterday, I'm going to drop the link for a Replit, and you can go ahead and create a Replit, and you're going to be starting exactly at the same spot that everyone else is. Let me grab this Replit link. Replit. Where is it? Okay, there we go. So allow. So I'm going to drop the replit link. Boop, 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 boop. Okay, so I just dropped the replit link into chat. You can go ahead and create a replit account. I definitely missed the HTTPS one. You can just type that in yourself. And then we're going to actually now add this to the screen. So you can see in the environment we made. If you don't have one, just go ahead and do go over here and just create a new replit and make a Python replit. Right, so just to create a new replit and make a Python one, name more if you want. I'm going to pick it up from here. Let's see. Yeah, I like switches in C++. Looks like match works basically the same. Yep, for sure. Okay, cool. We're just going to use their main file that they started for us, right? And we're actually going to do a few things. I forgot I should have done this already. But we're going to first look at sequential. Comments in Python, you do a hashtag or a pound or dollars. I mean, not dollars. Hashtag, pound, or I forgot what else people call this sign. But yeah, you do one of those real quick. After that is done, okay, so we're going to write sorry, I was checking something, sequential. So sequential control flow. So sequential control flow, again, is in your general statements. Is you can only have one if. Okay, I was just trying to write that. And if you actually want a section of code, a section of comment, you can use triple that. Anything in case in triple quotes. It's been a while, been a hot second. So anything in case in triple quote will get treated as a comment that you can have spaces in between. So I'm just gonna do this, delete that. It's trying to be smart and it's not doing what I wanted to do, but that's okay. So anything in case in triple quote is just a long block comment. So we're gonna write this out, right? So for conditional, you can have unlimited, infinity, or 0 if statements. And then you can have only 0 or 1 else statements. Multi-line comments. I call it comment blocks. Fight me. I'm just kidding. Thank you. Yes, they're called multi-line comments. If you just use hashtag for single, and then use triple quote for multi-line comments. I love it when ChatTop jumps in and helps me out. I struggle sometimes, but that's okay. So that's your sequential control bar. So for example, I can write name is equal. I'm gonna do CNAME is equal to, okay, real quick. We're actually gonna go over something real quick. It's that there is many different types of variable naming schemes, right? We have something called camel case, and there's something called snake case. I assume most people, if you're another primary course, you know the difference in these two. I kind of wrote them in the cases. Essentially, for camel case, whenever you run into a new word, you just uppercase the letters. Kind of looks like the humps on a camel's back. For snake case, whenever you write a new word and it's like where you replace your space with underscore. I am personally, technically I think it's called in PEP 8 standard, which is the standard that Python follows. They use snake case. Camel case is a way to separate the word in a phrase by making the first letter each word capitalized and not using spaces. Exactly, because in programming we can't have spaces, right? So if I wrote test space file, right, that is read as two different things. So that's why we use things like snake case or camel case. In camel case, you use uppercase letters for each time you have a new word that is separated by space. Snake case, you use underscore. You guys can say this so much better than I can. Snake case refers to the style of writing, which each space is replaced with an underscore. Camel case is where in each place, instead of underscores replacing, you just don't use space and you just capitalize the first letter of each word. And type H standard string snake case, so we're going to stick with snake case just because that's the standard that Python decides to go with. So first I'm going to do C_name, which you can, which is equal to, I'm going to grab one of you guys from chat. S_name is equal to, I'm going to put myself, and then we can write conditional statements, right? So I can say if C_name is, well, okay, actually, I'm going to write this. If, I actually didn't talk about this. We're gonna skip around a bit. So we're gonna learn about accepting user input real quick. So to get input from a user, we have in Python, we have something called input, right? We know how to, we know how to display something to the user already, display something to the user or interact with the user through outputting things. We use print to output things to the console for the user. And the opposite of that is what we call input. What input does is it prints out a statement and then it waits for the user to type in something, and then it reads in from std in, and then it stores it somewhere. Or you don't have to store it somewhere, but generally if you use input, you do want to store it somewhere, right? So this is how you interact. This is how you display something to the user. This would be how you get something, get input from the user. And how this will work is first we're going to create a variable, right? So I might call a variable which is let's call a name. So I'm going to say name is equal to input, and then input, what happens is the function, and that means you need to give it a prompt, right? So this prompt is what's printed to the user, so for them interactive. So we're going to do input. Yes, input function takes input from the user, correct. So we're going to input, what is your name? Question mark, right? So this will be printed out to the user when it needs input. So we're going to go to if statement. We're going to do if name is equal to C_name, which is a name from chat, right? I can then do print. I want to output something, right? Hello, string, hello, person from chat, right? And then I can do an else if statement, right? So this is the thing I want to consider, right? Else if is, so if it's not someone from chat, if name is actually equal to S_name, we want to do print welcome back streamer, right? And then we can do that. And then remember I talked about a catch-all case, right? I can just leave it here, right? But technically there is the case that it can meet none of these demands. So I can do an else statement, which you don't need to provide an actual condition because it catches everything else. So I'm gonna do an else statement, and then I'm gonna just do print, hey, you're not supposed to be here. There we go. Yeah, like output and input. Yes, exactly. Print uses the output to output the context, and input uses to take input from the user, like the whole content until a new line character. Yes, that's exactly it, right? Well, technically, input in the background, all it does is it reads from std in until it reads a delimiter, which in the case of the delimiter is a new line delimiter, and then it will just stop reading, and then it will toss the left or right and just store your input wherever you want it to go, right? So for example, if I run this, it asks me what is my name, and you see it pauses, right? Because it's waiting for input. And if I put Kev, you can put it right back to me what welcome back streamer. So all it does is it run this statement. Is Kev equal to is the name provided equals to the chat's name? No. Is name provided equals to the streamer's name? Yes. And then it prints this out, right? So now if I run this again and I put out our chat name I just picked out. So it says hello person from chat, right? Because I picked that up. But if I put in, let's say, anything else, it'll say, hey, you're not supposed to be here. And to make this even stronger is conditions, even for blocks, doesn't just work with these condition, right? We saw that in the condition when we talk about condition, there's like the keyword in you can use, right? So I'm going to change chat now into a list. So it's going to be a list of name from chat. make this a string. So it's going to be a list of name from chat. I'm going to see what else I can say in chat. If I see your name, sorry, you're being voluntold for this experiment. Oops. Right. So instead, what I will change here is, and do if name is in C underscore name. So what this does is it using the in keyword, it's saying check what for this value, what in this. And now that allows me to provide more than one type of user from chat, right? I can do ANUBAB72. And they still know it's from chat because all it does is it goes, checks this name, if it's in this list, and it is, and then returns that, or prints that out. But yeah, so this is sequential flow. And then I can technically have more, right? We talked about how I can technically have elif, and I can do name is equal to apple. This makes no sense. Don't mind me, though. And then I can do that, and I can do print. Wait, you're an apple? Oh, that's just applied, but apple, question mark, right? So like I can have more than one elif statement. I can technically, if I really want, I can take that out, right? So now if I do anything else, nothing just happens. Because that's what's supposed to happen. The trace back here was just replit glitching for a second, but you see nothing, like it just gives up and nothing happens. If I, let's say, do the name that's in the list, right? If I do, well, let's do my name, right? If I do my name, also nothing happens. So I have no condition that's being triggered off of my name. But if I do, let's say, a name from chat, the condition still exists, so that still works, right? And that's the same thing, right? I can technically leave the else statement out. It just means that if I leave the else statement out and keep all the elif in, I'm going to run that again. If I do apple, I will get the thing that triggers on apple. If I do anything else, there's no more condition to catch anything else. That's except for the ones that are listed in the if and elif blocks, or statements in the if block. So now we're going to move over and talk about loops, right? So we have talked about the idea of two types of loops, which is for loops, which in Python you have for each loops, and they have for I loops. So like mentioned before, for I loops are more your traditional for loops, right? We're iterative through a range of values, generally from a starting point and an ending point. But the range of value are generally indexes, so like we'll enter it through numbers, right? So we go from, like, say 0 to 5, or 0 to 8, or 0 to 20. For each loop is a unique higher level ability that is built into Python specifically, which allows you to do things like this for, and you, okay, now I should probably do this. So this general structure is for var, so you give it a variable name in something that's iterable. Did I not write that? I'm gonna write this real quick. This is called iterative control flow. You come back here. If it's something that's iterative, what it does, it will go for each thing. What it does is, let me do this, and then I'm going to do this. For each element, we call each data or each value within the list element. So for each value, for each element, or in any iterable thing, for each element in iterative object, you assign var to it in the order that it receives. So all that means is whatever your variable is, it will become each item in it. So for example, if I make a list called cat underscore names, and I'm going to set this equal to a list, and you can also build lists, right? We kind of talked about this, which we'll actually introduce in a few once we talk about the other type of loop that is within our disposal. But for right now, I'm going to hard code in this list of names, right? So I'm going to start with an iterable object. An iterable object is like a list. And with the list, I'm going to now build out cat names. I'm going to call it, give me some cat names, chat. Come on, let's spice this up a bit. Give me some cat names you can think of, something good, something fun. What would you name your cat? If I gave you a cat right now, Joe, okay. I don't know, mate. That's pretty weak. We already called coffee Joe. Okay. Oops, I'm gonna go back out, create a new string. I'm gonna do, I like some of these. Is that what, Mitty? Or we have I can't pronounce some of these already. Dog. Okay, I'm putting that in. I actually think that's pretty funny. Yeah, it's dumb, but it's pretty good. Puzzy. Okay. Then we can do tour. We can do. We can do, what is that? OSIH. We can do I do MEENONIE. Doraemon. You're so funny. Okay, we'll throw that in. Okay, that's it though. That's all the cat name we really need, right? So what happens is I would do for cat name, right? So I'm gonna use a singular version in cat names. Print cat name, right? So what I'm saying is I named this variable that I want to use cat name. So it takes cat name and it goes to the iterable object saying, okay, now cat name on the first run of this loop will become Joe. Cat name in the second run will become whatever this is. Cat name on the third run, fourth run will become dog, Puzzy, Toro, and so on and so forth. Doraemon is the last one. Oh, Shin-chan? Okay, sure. This is the last one I'm adding. You had a few. There we go. Okay, so if I run this, you'll see that it will iterate through each object, and you will get, if it ever chooses to actually work. Oh, I gotta, so you can comment. Oh, fun fact, quick commenting out if you want to comment on multiple lines of code. Just highlight it, hit control, hit backslash. And most IDE and most programming languages, they'll comment out anything and in chunks, right? So I can recomment them if I need. You can see it just printed in order, right? But what is I don't even know why I said but. That's really it. This is for each loop, right? Oh, what I was saying, but is I can make this anything, right? The variable doesn't matter as long as this variable is, I'm just naming a variable saying this variable is going to take on also answer that, and that's the variable I'm going to use in here, right? So for example, if I name this variable like dog and I run this, it'll give me an error because cat name isn't defined. But if I put dog in here, even though I called it dog, which makes absolutely no sense because it's a variable, it still works, right? All it's doing is saying take this variable and then go through this iterable object and set this variable to everything in that object. And but yeah, that is your weakest loop, right? If you think about this in terms of rings, right? This is gonna be painful, but I'm gonna do this anyway because I hate myself. Yeah, this is gonna be super painful. If I wanted this, really needs this small. Oh no. What have I done? Okay, we're not doing that. I was gonna draw an ASCII, but that's not happening anymore. But you can think of these as rings, right? So we can do ring 0 being the most outer ring. So I'm gonna do this. So I'm gonna do ring 0 is the most outer ring. But so actually no, we make ring 0 the most inner ring. Saying this out doesn't make sense. The most outer inner ring is a for each loop. And how this works, you think about, they kind of eat each other, and there is that means anything that's inside another ring can be solved by something, a bigger ring that's outside of it, right? So ring 2, which is bigger than ring 1, ring 1, which is bigger than ring 0, which means ring 1 can do anything that ring 0 can do, but ring 0 cannot do everything that ring 1 can do, which is our next type of loop, which is called for I loop. And this is your pretty standard loop in most programming languages, right? So it's your index loop, and that just loops through a certain range of numbers that you can use as indexes or indexes. Cat names equal A, B, C, D for cat names and cat names print. Yes. Okay. We don't code golf here, but you could technically write things. I think, let me think. Yes. In Python, you can write things all in one line. Through certain mechanisms. Actually, you cannot, because Python is syntax, maybe you can, I don't remember they made it possible, but there's a type of activity called code golfing, which is essentially like you try to write achieve something in the least amount of time possible. I think in Python you can't. I usually do it in C or C++ because it's not a syntax-based language. It's a delimiter-based language, which means like it looks for certain delimiters to determine which it breaks and stuff. It works. You can do a lambda statement. Maybe that might actually work. I haven't done that before. Let me check actually. Now I'm curious. Let me see if you can do this with a lambda statement. So, I think you're right? You would just okay. Yeah, you could do that. Oh yeah, because no, yeah. You can also if you want, you can also use list comprehension, but we're not gonna go into that for right now. So the next thing we're gonna look at, I'm actually gonna copy this up. I'm actually gonna look there. Is gonna be a for I loop, which is your more traditional for loop. So I'm gonna do for I. This is just, I'm gonna actually write this out. So for your more traditional loop, I'm gonna do. Okay. So for I, where I is really just a variable, a temp var. That is just stands for index, right? So because we're just indexing through it. For I, just it's index for loop. So for I, or any variable you like, in Python, you have to do this is you need to use the keyword called range, which is a function that generates number from X to Z. But yeah, so you would just use for something in range, and then you would leave it, right? So we're gonna take a look at range or how range behave real quick, even before we do that. So if I do print range of 4, I think this works. If it doesn't, I'm sorry. I'm pretty sure it does. Right? So it says range of 4 looks like this, 0 to 4. So I'm now going to print each element in that, right, and see what that really means, right? So this is saying the starting number is 0, the ending number is 4. And how, if I do print, I'm going to do for I in range of 4. You're jumping ahead a bit there. Remember, length is just utilizing the whole same concept, but we're just getting the length of something. Hey, chat, for people who are starting off, it's nice to know all this stuff and don't think I'm just going to be behind the scene. Actually, once you get comfortable, you can explore things, how they are working under the hood. Like, for example, iterative next function for basic model of Python. Don't worry for now. Just note what it does. Yes. A lot of this stuff comes with breaking them down, right? So if you're learning new, which is why this is really hard, we're not going to do that deep, but I appreciate the comment. And yeah, there is, when you do a lot of this because it's such a high level language, which actually happens, there's already a lot of code written that's doing it for you manually, right? Including like memory management, including garbage disposal and all sorts of stuff is already written out, so you don't have to write it. If you really want to learn, start writing assembly. If you want to write maybe a bit higher, you can write in machine code. If you want to write a bit higher than that, you can write maybe C. If you want a bit higher than that, maybe C++. A bit higher, maybe Java. And then if you want to go a bit higher, maybe we can go to Rust or Python and so on and so forth. But yeah. But from where we are, we're going to do for I in range, and it's yelling at me. Why? Why is it yelling at me? Because I need to use a comma to end that statement. I'm going to need to hop down here. I'm just going to print I, right? I'm going to see what I is. If I run this, you'll see that I goes from 0 to 3. And the reason is, now we're going to talk about the properties of range. I'm going to scroll down. Oh, you guys should have said something. It was so tiny, you couldn't read as well. There we go. I'm going to do properties of range, which is range is a function that takes 3 arguments. So you have arg1, arg2, and arg3. And what those arguments stand for is arg1 is your start, arg2 is your stop, arg3 is your step or jump, however you want to use word there, right? So I like to use start, stop, step. And start, okay, and the minimum number of args you can give it, so for range, the minimum number of args you can give it is 1. The maximum number of required args. The minimum is 1. The maximum is 3. If you only give range 1, so if I do range and I only provided 1 argument, that arg is the stop argument. So if you just only provided 1 argument here, that argument it treats as a stop and it assumes that you're starting at 0. Assume start is equal to 0. I'm gonna just do that for the sake of it. And if you do range and you use 2 arguments, arg1 becomes your start and arg2 becomes your stop. So, and then 3, we kind of wrote it up here, right? So 3, you would have your start, stop, and your jump or step. And we'll jump or step in just how many ways, right? So by default, if I just did range of 4, it started at 0 and it jumped by 1, which means it increments by 1. If I put the jump at 2, it would have printed 0. And then it would jump, instead of printing at 1, it would jump by 2, which means it would go skip. So it'd be 0, 2, and that'll be it, right? Because it can't jump to the next one. And it ends at 4. And the key thing to remember here is your stop. I'm going to write this out. Stop is exclusive and not inclusive. Meaning, wherever you put in as your stop value, the range does not include it. It excludes it. So you want to keep that in mind. I shrink that a tad bit. So now we have range. We understand how range works, right? So like I did a for-i. So right. So if I'm using a for-i loop, if I want to achieve the same exact thing, it's a pretty minor code modification, right? So I'm going to copy this. I'm going to put it down here, and then I'm going to look at this. I'm like, okay, so I want to change this to a for-i loop. So first, I'm going to use I, right? So I can grab the index, and then I probably want to use range of cat names, but range, again, what it takes data type of integers, which means I can't use cat names. Cat names is a list. So what can we do, right? What we want to do is we want to iterate through the whole entire list of cat names, which essentially means I want to know the number of items in the cat list is how many times I want to iterate through. And to get the number of items, we use a function, a really amazing function called len, which returns the length of an object that it knows how to define how to do, right? So in this case, I'm going to do len of cat names. And then to show you real quick, I'm just going to print that out before this. So I'm going to do print len, which just stands for length of cat names, right? So I'm going to print that out. And then do you think this works? No, right? It doesn't, right? Because cat name doesn't exist in this loop. So I'm going to use I. But if I only print I, you're going to see what's going to happen, right? So this runs. So you can see that here. It says cat names. There's 11. Did I really write 11 names in cat? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I didn't even realize I wrote 11 names there. Holy heck. That actually caught me off guard. I was like, what did I do wrong? But yeah, okay. So you can see here, it printed out 11, right? So that's the length of the object. And then it went through and printed out 0, 1, 2, 3. And that's not what we want to do. And this is what we get into what we were talking about yesterday. List is ordered. So I'm going to do hashtag list is an ordered collection of objects, right? What that means is it has something called indexes. So I'm gonna do. So for example, if I took a list that goes A, B, C, D, E, which I need to do quotes around them, but for this demonstration, I'm not going to, right? What it does is it knows that A is an index 0. It starts at 0 because we're computer scientists, and for some reason we thought we want to count at 0 by going 0 instead of 1. So we start at 0. So that's why our indexes start. And this is 1. This is 2. This is 3. This is 4. And that means if I was to want to grab something, or if I want to reference that list and grab a data at that specific with the object at that specific location, I would say, let me get. Let's call this list letters, right? So if I say letters, I want a specific letter at a location. What you would use is you use a bracket saying, I want to go to the letters list, and I want to go to this exact index location, right? So if I want the letter A, I would do letters and then do 0, right? So I'm going to grab whatever's at index 0, which we know is equal to A, right? And if I do letters, and I'd say I want to grab whatever is in index 4, I would get E, right? Then here's the part is if I do letters, and if I say I want to grab whatever's index 5, it doesn't exist. And what you would get is actually you get index out of bound error. Which all that means is you just went past the allotted index that we could possibly be at, and that's perfectly fine, right? So now we kind of have understanding of how list works, right? So we know that the length of letters is equivalent to 5, right? And do you see what we're noticing here, right? So we count indexes from 0, but there's actually just 5 indexes, right? So it's 1, 2, 3, 4, 5. And we use that to our advantage. And when we use range, right? Because you remember how range works? Range starts at 0 and goes up, but not includes the stop you give it. So in this case, if I do range of the length of cats, what's actually happened is it gives me the indexes up until, but not including 11, which happens to be the index of the whole list, right? But that's why when I print it, I print it. If I just print out, I get 0, 1, 2, 3, 4, I mean down here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But what we want to do is we actually want to reference. Right? Down here we talked about how for letters, when saying go to letters and go to this index location, we want to do the same thing here. We want to say cat names. For the list cat name, we want to, every time we print, we want to increment this by 1. But before that, we're going to print out the cat name and whatever index this is, and then we're going to increment that by 1. So if I'm now running it this time, you can see I get an error. Why do I get an error? Because it's cat names, not names. Right, there we go. So if I now run it, you'll see it prints out first. This is from the for loop from above. This is from the for loop from below, and it gives us the same result, right? But we kind of talked about this. Problems that the for each loop can solve, all for I loops can. But not all problems that for I loops can solve, all for each loops can. And this brings us to our next ring, an even bigger ring, which is while loops. And we're going to scroll down here, and we're going to do quote, and then we're going to do one here. I'm going to do while loops. And while loops it's a really unique place to be, right? While loops is the mix of a sequential loop, right? What we kind of just did is for loop is essentially a sequential loop. While loop is a conditional loop, right? So we kind of are taking a few of the things we talked about prior. Well, for loops doesn't always have to be sequential. There's a way to jump around and do things, but you can, let's say it's the sequential version of a loop, and now we're going to say while loop is the more conditional version of loop. And how that works is it's while is the keyword you use, and you provided a condition. And how it works is when this condition is true, it will perform whatever is in that loop. But when the condition becomes false, it's the loop will stop executing. So while condition is true. In Python, it's just this. TRUE. Yeah, TRUE. Execute. Run loop. While condition is false, run. Do not. Move past the loop block. Well, so you move past the. We can be more specific, while loop block in this case. So what this looks like, if we do while, let's say while, and this is really useful when you're taking input from users, right? So I can do while, so I'm gonna write some new code here. So while user input, I'm gonna it's equal to input. I'm gonna do what is your user input is equal to name of dog, enter, quit to exit, right? This is a really common use case for a while loop, right? So you give it a condition. We're not going to talk about escape sequence, but you give it a condition. And if the condition is met, it'll keep running. If it doesn't met, it just stops running, right? And for my sake, I'm going to do a /n. So this is called an escape character, which means it might be a normal letter that will interpret as a string. When you use an escape character, it tells it that, no, don't interpret that as a string. You escape it, so this is consider this not part of the string, and do something else, right? So doing an escape character where backslash, no, that's a, that's a backslash. Backslash n means just print a new line. So I'm going to do this. So name of a dog, enter, quit to exit. So I can say while user input does not equal to quit, we want to run this loop, right? So this is really useful. So I gave it the condition. And as long as the condition is not met, we would maybe this is what we're going to do, right? So maybe we'll do this. I'm going to do this really simple. So I'm going to make a list called maybe called dog underscore name is equal to an empty list. I can do dog underscore name dot user dot append. Append is a list method that allows you to add to the end of a list, right? Like you're appending an object. And so I'm going to do append user input, right? So what I would do is I would just copy this down here. And what's really cool is in most programming languages, you have something called like a do while loop. Unfortunately, that doesn't exist in Python. What do while loop does is saying do this once, and then afterwards you will do it on a condition basis. But that doesn't exist in Python, which means I have to write this on top and write this inside. There's ways around this, but until you get more familiar with the language, you probably want to stick to more fundamentals and actually try to understand what's going on, right? So this is really easy to read, right? I created a dog list or a list called dog name. I then created a user input that takes the input and only clicks on exit. And I did dog name underscore append. I did user input and then did while user underscore input does not equal quit is my condition for the loop, right? So it's saying if the user don't enter quit, you just keep doing this, right? You ask the user for a new name and you add it. Oh, I guess I'm kind of trolling here. Let me think. Yeah, because what I could totally do is here's a way to do it. I can just remove this, right? But what you can do is you just define user input and you set it to something at first. This is also a way to do it. If you more know what to do, this is what I would normally do is I would just have to select empty string, right? So this is true, right? So because it's empty string, it will say go through while user input is not equal to quit, which empty string isn't, it will ask you this. And at the first time, it'll keep going through and do that. Edge cases when user input quit is going to be a dog name. Can I toss you out a window? Yes, edge cases would exist. So if you want to take into account such thing as you can do something, right? Well, if they're going to do that, I don't know what to tell you because I can tell you to say anything as a dog name, right? I can name my dog X, Y, and Z. I can name my dog anything. But yes, so I'm going to run this program now, right? It's going to run everything above. And what we talked about, remember, we can comment things out. So I'm just going to highlight everything above and give it a quick control that everything got comment out. Even my group comments can comment out, which is perfectly fine, right? Because I don't need them right now. So I'm gonna run this again so I don't get all that clutter. And so now I'm gonna say enter name. So the first second I enter quit, it's like, oh, we're done. GG's. Loop ended because we gave it quit, which means when it tries to go through and runs it again, it'll go, yeah, that doesn't work. But do you know what's actually, we're gonna run this a bit first, right? So I'm gonna write, let's say I'm gonna write I'm gonna cry. Oh, give me some dog names now. Give me some dog names and name it. I was like, I'm not good at this creative stuff. Here, chat, throw me some dog names. GG's, woo. Okay, this is the worst chat ever, but I do like that. I'm gonna put cat in there. Give me something else. Pup. Okay. Johnny. Lie. Sits. Roll. Wolf. Grumpy. Oh, what is that? What is that character called? What am I thinking of? Snoop. And then what is that character called? Garfield? There we go. I can't spell those, so that's a problem. Field, I think. Whatever, right? You got an idea. Crawl. Okay, I think we have enough chat. Thank you for your names. Appreciate it. Right. So now, once I'm done, I'm gonna write. Oh, I messed up because what I probably wanted to do is I want to print out the user list of dogs. So I'm gonna type that all again, which I hate myself for, but that's another problem. So I'm gonna stop, rerun that, and then I'm just gonna retype this. I know Garfield was a cat. That's the fun part, right? I'm not crazy yet. Keyword there's yet, by the way. So I'm gonna do a few of these. Wildlife. But you're gonna notice a problem once I quit this program. Can anyone think of the problem right now on the top of your head? It's a pretty common problem. So if you code it in Python before, most language you might run into. Does anyone know what the problem is gonna occur the second I write the word quit? Any takers from chat? Going once, going twice, going a third time. Sold to no one. Okay. No, that is not the problem. That's a good guess, though. It is going to be a raw list because I'm not going to provide any formatting, but that's not the issue. Can we think of the issue, chat? We have so many beautiful minds here. Yes, there we go. That is the common issue that happens, right? So if I do quit, our data now contains the word quit, right? Because there's nothing stopping quit from ending up in the pen statement, which then adds it to the list. With that being said, that's a problem. So how do we fix this problem? That's not true. You thought, well, we're gonna talk about break, but so if you're going to academic setting, especially if you're gonna end up taking like computer science 101, computer science XYZ, correct. So this is the most optimal solution. I was not going to use this solution at first. I want to show you a few ways, right? So one way to solve this, I'm actually just going to make a copy of this loop. So one way to solve this is like what you mentioned, right? We're playing with the thing. But do you know what the problem if you do this becomes? There's still a problem. What's the backslash? I don't know. You use a Mac. That's like you do that to yourself. Actually, you're in luck today. I picked up a project laptop from like refurbished. I'm gonna work on later. So it's happened to be a Mac, and it looks like the back key is right here. It's your question mark. It's above your Control Alt. That's where it is. There you go. I picked that up for some testing purposes. Don't worry about that. That's a project I'm gonna work on after I get off stream, but whole nother story. So it is it's above your Alt key. Yeah, I get to do that now. I used to not have a Mac and I just never did that. Indexing of list comes into play. Talk -1. Okay, so the problem becomes this, right? Is because we declared input as empty string. So empty string will be first appended to the list. So that doesn't solve our whole problem. It solves maybe a bit of it, right? We don't have quit in it with empty string in it. So how do we solve that? There's a few ways, right? So one way is, let's look at this statement. It flows a lot. You also want to think about logical flow, right? The whole point of Python is its readability, and want to take advantage of that, right? So you first grab something, then you add it to the list, and we want to be able to keep that. And what we would do is, what is a type of control structure we talked about that becomes super useful in a situation you want to consider a condition before you act upon an action? Add an if statement. There you go. There you go, chat. You're all geniuses. Wonderful geniuses. Conditional. Whoa, look at that. So yes, so you can write it in both ways, right? So in the case that you get the input first, get the input first. So you would just write it right here, and you would just do if boop 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 boop. You just use the same condition as your while loop, right? You just take a copy of this and you just drop it in here, and then you just do this, right? And then you just do dog name that append. If you would say if it does not equal quit, you do that, right? And then here's another version of this, and this is where the kids were super excited, right? You can write it is that if that you can just break this back out. You would just put it underneath it though. So I'm gonna do that, right? I'm gonna do that, and then you can just do if that. You just use you just do a break, right? And so now we can talk about what break does. So those are really your two ways of doing it. You can also for the edge case we did up here, right? You can just put the if empty string if you flip those two, and so on and so forth, right? So what break is, right? Break comes in handy. So if you're in an academic setting, there might be things like you can't use break, because break makes things a lot easier, because like, oh yeah, you're running something, just break, right? So like you just break, and it things become a lot more simpler, and there's a lot more shortcut when you can just throw in the word break, and also the word continue. So in academic setting, you wouldn't be able to do that. That's why we like to do things both ways around here. In a non-academic setting, in like a real world setting, break is your friend. It's fine to break. Just know that you might run into a case that you don't remember you used a break there, and that might cause you some unknown conditions or something to happen. But in our case, break is fine. And what break does is there's a few iterative do a comment. There we go. We discussed yesterday about empty string is false. Yes, that is 100% true. But yeah, so iteratively, oops, I was doing this. So in iterative, do you know why? I'm curious. Well, curious. Does anyone know why sometimes like you see like, oh, I'm just typing and then like the word kind of auto completes itself? Anyone know what feature that is? I'm just curious. Anyone know what feature is causing that? Or have you ever wondered why it's doing that, right? So if I type in like if I just do under and then like sometimes just auto fills the rest of it, there's a really specific native feature to Windows that does that. It's a pretty cool feature. I wonder if anyone else is aware of it. I have it on because I can't spell for the life of me, right? So it's amazing. How to get / in Mac? You're actually like messing with me, right? I'm pretty sure it's just the same thing. It's above your enter key, but I will pull back out the MacBook, open it up. Yeah, / is just above your return enter key. Like you're actually just messing with me at this point, right? Like it's right here. Let me put that back away. Okay. But you're actually just trolling me. There's no way. For sure. I got you anytime. Just let me know. Okay. Okay, cool. So yeah, so what was I doing? I totally forgot. He's new. um, what was I talking about? I was talking something. Oh, iterative control flow modifiers. And what these are words or keywords. They're keywords. They are keywords that modify iterative. I did not spell iterative up there. Iterative. All right, the keywords that modify iterative control flow. And I think there's three. The tool that I always use and remember is just continue, which essentially saying skip the current iterative run and iterative pass and move on to the next pass. Break is saying skip all following iterative passes. Cool. There you go. No, for sure. Anything you need, chat. Well, most things you need. I cannot say anything you need. Most things you need. If I can help, I try to help. But yeah, so these are the two really key ones, right? So I use break. What break does, it just skips all the following iterative statements, so it'll run iteratively till break. So if let's say I hit quit in the beginning, it breaks, and then everything else is just skipped, and any other iterative run is just skipped and jumps back out. So you can think of it just breaks out of the while loop, right? So if let's say my condition for the while loop was more like a for loop while, so like while 8 is not equal to 8, right? And maybe I'm at like a is equal to 3. If I use break, I just jump right out. Or you could use continue, but in certain cases, right? In our case, in certain cases, right? So continue skips the current iterative pass, but it moves on to the next iterative pass. Completely breaks out the whole entire while loop. So break is more destructive than continue is on a fundamental basis. But yeah, okay. We just went over while loops, we know for loops, and so essentially now we're in just in our case, yeah. You have to word it a certain way, but yes, and just in our case. So for what we're gonna talk about right now is while loop is the most powerful loop, which means every problem you can solve with a while loop, you can solve. Every problem you can solve a for loop and a for each loop, you can solve a while loop. Do? What do you mean do? Do what? Do while? The do while doesn't exist here. I was saying this earlier, right? Do while does not exist in or am I trolling? I'm pretty sure do while does not exist in Python. I'm gonna make sure I'm not trolling, which is fine, right? Google's your friend. Do while Python. From my recollection, do while does not exist, but I could be wrong. Does do while exist in Python? Am I thinking of something else? I don't think do while exists in Python. I could be so wrong. Let me check. It would be so bad if I'm so wrong because I actually teach Python as introductory to computer science in college. Okay, yeah, okay. It doesn't exist. You honestly scared me for a second. I was like, wait, am I so out of it? Okay, yeah, okay. So that's what I was saying earlier, right? So in some programming languages, what you can do is you can do something, and then you can say while a condition, right? It's something like this, right? So what this does is saying at least the do always runs once. So do that, and then while it's true, continue to do that, and that's really useful. Yeah, no, for sure. You're all good. It's always great for a question. It makes me think, like, do I really know what programming language I'm in? But yeah. Yeah, there we go. I should have explained it, right? Do whiles is really used and in the statement where you want to do some action once and then on condition to continue doing it, right? Right. So like you always will do the code once and if it's true, it'll continue to do the code. If it's false, it'll stop. And it's actually, it would have been amazing, right? So like instead of me writing it like this, need all the break thing, right? If I had do while, so in the amazing way, if I did have do whiles, I would do this, right? I would do. I'm basically writing in C, but if I did, I would do, right? And I would just grab this, the first copy, right? So I would do this, and then I would do a while. Do while is just a modified while, and it's just like more powerful, as in it's not more powerful, it's just more powerful. So it would do, then I would give it the condition, the same condition, right? So user does not quit right here. And what this does is it will say it will run this at least once. The do body always runs once. And then if this condition is true, it will continue running the do body. Yeah, I'm confused. Yeah, no, do while does not equal while. Do while is a specific case. It's a written version of while. It's, you know, like we kind of did this up here, right? We're basically creating our own type of do while. And in real life, realistically, I don't know. So in real life, do while does one iteration max. Oh no, I meant to pull this. So yeah, but in real life, can't think of a scenario where you want to use do while as a replacement for while. I can think of many. And it's generally in the sense of user input, right? It's basically do while is you just use it in any case where like you want to do something at least once at a bare minimum, right? For example, if I'm making a to-do list, right? Or anything that really takes input from someone, doesn't matter. I can think of many times where I'm like, oh, I wish I had a do while loop, right? It's any case that you would do. So maybe let me think of a possible real world example of do while. Let me think. What's a good real world example of do while? I just use it so much in user input. Let me think of a real world reason of doing a do while. I mean, let's say I can't think of a great one. Did someone drop one? Let me think. Let me read. Yeah, exactly. This is just at least, so one essentially considers the condition of the while loop beforehand, which is a regular while. One considers a condition of while loop after, which is great. I have no absolute clue about a real world example. Sorry, brain's fried. No clue. I worked a 8-hour shift and then came on and started streaming. No clue. Realistically, can't think of one. If I do, I'll tell you tomorrow. I'm gonna sit on that one for a bit. But yeah. Any questions on loops or conditional or any of our control flow modifiers? Because I think if not, we're gonna take a chill break here. We're gonna go back to. We're going to actually save our talk and function for tomorrow, as well as our actual building for tomorrow, and we're gonna swap over to our questions. Any questions from chat? I'm surprised no one asked me to change the music, but that's perfectly fine. Awesome. Again, thank you everyone. It was great. A lot of amazing shout outs to everyone in chat. Basically, most of you guys all hopped on the conversation, joined me, shared some insight, your own insights. Great. Perspective is what makes life interesting, right? Everyone has a different perspective, a different understanding, and a different way to teach it, and it's great. I love it when chat interjects. You see, I don't get to do this as much anymore. No, you're great teachers, right? I've seen some of you guys for amazing things. You guys should consider teaching one day. But I do appreciate this. I'm gonna throw some of this in chat, right? Yeah, great, yeah, awesome, whoa. And then great teacher, I do appreciate this one. But I will say, I haven't been able to do a fun global hacker stream in a while. They keep giving them out to other people. I used to do a Tetris tournaments and stuff, and everything is super fun. Maybe we'll do that. Thank you. No, I just want to say everyone in chat is great. And I'm telling you, I'm going to take a screenshot of everyone in chat. Thank you so much. Thank you for coming. I'm going to grab a screenshot. No time to run of everyone in chat. And one of you guys better become a top 50 by next year this time. I will save this in my file. Let me save that real quick. I have now all of your username captured. It's fun of you guys. You guys are so great. Thank you. Yes, next stream, real quick. Next stream is going to be tomorrow. We're gonna be building. We're gonna build a Discord bot together, and we're gonna teach a bit of function real quick, and then hop into Discord botting. We're gonna build all that out. But hope everyone have a wonderful rest of your day and have a good night. There's no more stream after me until tomorrow at 5 a.m., which most of you probably won't. So make sure you get some rest in. It's gonna be wonderful. And yeah, join me tomorrow at the same time, 8 p.m. Eastern time, and we're gonna start building a Discord bot and have so much fun. Great. If you draw me, just make sure to mention that you met me at XYZ, so I actually make sure to do that. Yeah, for sure. I'm glad you know all your slashes now. It's great. It's a wonderful experience to know your slashes. Now, there's a point. I treat my slashes. I can't tell my left hand from my right hand, right? It's not instinctual. I can't tell my back slash from my forward slash. You need to take a second to think about it. It's pretty funny. 5:30 a.m. IST. Yep, it's early. It's great. It's wonderful time. But with that being said, if there's no questions, slashing all your problems, yeah, that's amazing. Have a good day, everyone. 5:30 a.m. IST. If you reach out to me, just remember to include that you met me here, so I would accept. And feel free to message me, right? If you want to message me questions, I'll be more than happy to generally answer them through LinkedIn. Only thing is, if you just message me part of it, I don't respond to those because I just hit accept and stuff like that. But feel free to reach out if you have any question. With that being said, have a good night, everyone. Take care. Actually, no. You should have caught it on the introduction slide. Catch it tomorrow, and you can add me tomorrow. But with that being said, have a good night, everyone. Take care. Or good day, good morning. Sorry, I forgot. Good morning, good day, good something. Get some rest. Enjoy yourself. Take care, everyone.